Howdy and welcome back. So in this video, I just want to talk about some guidance about interfaces or the public member functions that will essentially declare and allow, and that will allow users of our type to interact with objects derived from it. So what makes a good interface? Well, a good interface is going to be as small as possible. This will simplify an understanding as to how objects of our type can be used. Will also simplify debugging as well as simplifying maintenance. Moreover, our interface should be complete in that it will provide the behaviors necessary for objects of the type. In addition to this, it should be type safe in the sense that we're going to essentially avoid confusing argument orders. So we'll try and define or declare our parameter list to these functions in a sensible and consistent manner. And we're also going to attempt to avoid kind of overgeneralized types, like using an integer to represent a month. A better approach would be to say to use some sort of enumeration to provide further clarification in terms of how we'd represent a month in our interactions with it. We're also going to want to ensure that const is appropriately applied. All of the member functions who do not mutate the underlying state of the object derived from that blueprint should be labeled with const, and you do this by writing const directly after the parameter list. And again, only functions that have this label can we invoke when we're essentially interacting with a constant object of our type or a reference to an object a constant reference to an object of that type. The one other thing I'll go ahead and point out here is in the interface, we might also like to have member functions that essentially are used to imply some sort of attribute of that type when that attribute really isn't something that we're explicitly stored. So we store most of an object's data as an attribute. However, there are situations where the data is better off kind of computed on the fly than actually stored within the object's representation. For instance, our color class could define a member function of the public interface is gray that returns whether or not the color stored in an object is grayscale or not. To define grayscale for a color, we'd simply say the RGB components all have the same value. Now, instead of storing, say, a Boolean data member that's like is gray, instead of that, what we could go ahead and do is simply have a is gray member function that would check the values stored in the data members, return true if those values computed to a grayscale value, false otherwise. If we had stored, say, is grayscale maybe as a data member, we would have to update its value every single time the RGB values were changed. So in our mutators of RGB, we'd have to check to see whether or not, hey, did this assignment cause the grayscale flag to change or not? And anywhere else where those values were updated, we'd have to make an additional check. However, if we don't store this as an attribute, but instead compute the value on the fly, we don't have to have this check in multiple places. Instead, it will be computed as needed.